Welcome to part 4 of this video series. In this video, we will revisit the code projects we constructed in part 2, integrate them, and deploy them to Azure to the resources we provisioned in part 3. Finally, we will get the app running in the cloud. Let's crack on. We start from the backend, go into the project folder. First, we need to add 2 NuGet packages to the project. One is Microsoft Azure Cosmos. We need it to connect to Cosmos DB. The second one is Newtonsoft JSON. We use it to process JSON data, as Cosmos DB uses JSON to move and store data. Both packages installed successfully. Let's look into the code. Open up VS Code. Before this step, I made some changes. Let's go through them. In the models, for the WeekPlan class, I added JSON property attribute for each property, so we can define the property name that goes into JSON. I added an interface iSetting service. It is an abstraction to retrieve application settings. For now, it provides some settings of Cosmos DB so we can use them to connect to our database later. Not a surprise, there is an implementation class setting service. It retrieves settings from environment variables. I modified the service factory, added a new method, getSettingService. It constructs and returns an instance of setting service. Perhaps you already noticed there is another new class, Cosmos Persistence Service. It's an implementation of persistence service for Cosmos DB. It implements all the create, read, update, delete operations of WeekPlan. The key component to communicate with Cosmos DB is Cosmos Client. When we construct the client object, we provide the database endpoint API key, so the client is able to connect to our Cosmos DB and access data. Now we can use this implementation of persistence service. We go back to the service factory, change the getPersistence method. So now we get an instance of Cosmos Persistence Service. If you have implementation for other databases like MongoDB, MySQL, here is a place to switch to your choice. This fake persistence service is no longer needed. We remove it. Let's review the functions. For the getWeekPlan function, there is no code change from step 1. However, when we call service factory to get an instance of persistence service, now we get an instance of Cosmos Persistence Service. There could be other ways to inject an instance here. For example, by dependency injection. Dependency injection is supported in functions. To simplify code in this demo, I will skip it for now. Also, function supports input-output bindings to access Cosmos DB without writing much code. It could be a good option if the database had been fixed as Cosmos DB. In addition to this getWeekPlan function, I also added other functions to create, update, delete WeekPlans. One more thing, remember in setting service, we retrieve settings from environment variables. We need to configure them. Go to local.setting.json file, which provides local configuration for functions. I'm going to add some application settings in the values property. These settings will be read by functions as environment variables. I just added some keys of settings, but where can we get the values? Remember, in step 2, on Azure portal, we navigated through Cosmos DB account settings, keys. We saw the database endpoint, also the primary, secondary keys. So I copy the database endpoint primary key from the portal and add them to here. I set the database name as planner, container as WeekPlan. Both are fully customizable. Everything is ready. Let's open a new terminal. Start the function project. When it is ready, we have 5 functions available locally to respond to different kinds of HTTP requests, including GET, POST, PUT, DELETE. The functions connected to Azure Cosmos DB. Just be aware, for local development and testing, we could install Cosmos DB emulator on the local machine. To simplify the demo, I have skipped this. Let's move on. Now I'm going to test the functions. I use Postman. It's a powerful and friendly REST API client tool. Let's copy the URL and switch to Postman. In the Postman, create a request. It's a post request. Paste the URL of the function. Go to body, raw, JSON format. Paste a payload. Post the request. In the response, the status is 200, which means OK. Let me post a second one. Again, the response status is OK. Change the post method to GET. Send the request to get all week plans. The 2 week plans we just posted are displayed in the response. For now, the functions are running locally. We are going to deploy them to Azure, to the function app we provisioned in step 2. Let's go to Azure portal, have a quick look of the target function app. Here is the function app on Azure portal. I copy its name. We need it later. Go to functions, functions. There is no function deployed yet. Let's switch back to the terminal. First, define a variable for the function app. Paste the name I just copied. Next, publish the local function project to the function app on Azure. Oh, I typed publish incorrectly. Try again. Deployment completed successfully. Functions are available at the new URLs on Azure. We switch back to the portal. Refresh. We see all 5 functions are listed on the page. Drill into one of them to see details. We can carry out some quick tests here. Now remember, we configured application settings in local settings JSON. However, these local settings won't be used when functions are running in the cloud. We need settings for the function app. Go back to the function app settings, configuration. We need to add some settings as we did earlier. In local environment, we can do it manually by clicking New Application Settings. Or let's do it by commands. Switch to the terminal. Define variables for the resource group, Cosmos DB endpoint, Cosmos DB API key. Run az function app config app settings. Give the function app name, resource group, the settings. The command completed successfully. Switch to the function app on Azure portal. Refresh the configuration. The new settings are displayed in the list. We are going to test the functions. Go back to the overview, copy the URL, go to Postman without restarting the function app. In the Postman, replace the local host with the URL we just copied. In the request body, modify the JSON payload. Post the request. In the response, we see the status is OK. We could carry out more testing on other functions on get, update, and delete, but let's save time and move on. One thing you may be wondering about is how data are stored in the database. We can view the data in the Cosmos DB without installing any client tools. Switch back to the portal, go to the Cosmos DB account, open up Data Explorer. Cosmos DB supports multiple API. I'm using SQL API, which is the default. In the Object Explorer, we see there is one database planner. In the database, currently there is one container week plan. We can run SQL query to query data. If we query all data in the container, we see all the week plans we posted earlier displayed in the results. Now the backend and the database are ready on Azure. Let's move to the front end. I already opened the front end project we constructed in step 1. Remember, in app.js, we fetch data from an URL provided by an environment variable. For the local development environment, we defined a local configuration file .env.development.local provided URL there. We need a separate configuration for the cloud environment. Let's clone .env.development.local, rename development as production. Then we replace localhost URL with the URL of the Azure Function app. Save the change. One more thing, we need to handle page not found error just in case. I added a 404.html in the public folder. It is a simple page just for demo purpose. Everything is ready. Let's go ahead to create an optimized production build. Build is completed. I created a build folder with a production build of our app. Let's go into the folder. The static subfolder contains bundled JavaScript and CSS. Also, index.html and 404.html are generated in the root folder. All looks ready to be deployed to a static website. Remember, we provisioned an Azure storage account to host the static website. Let's go to Azure portal. Have a quick look. Here is the storage account. I copy the name. It will be used later. We go to Storage Explorer, Blob Containers, $web. It is the root folder of the static website. We can upload files by clicking the Upload button at the top, or let's do it by command. Switch back to the terminal in VS Code. Define a variable for the storage account name. Call az-storage blob upload batch from the local build folder to the static website root folder. Give the storage account name. The upload was successful. Switch to the portal to check. Previously, there was no files available. Refresh. We see all the files and folders in the local build folder have been uploaded. Let's check some settings before we test the website. Go to the static website. Here is the URL of the website. Let me copy it. Index document name is index.html. Arrow document path should be 404.html. Let me fix it. Save the change. Okay, all are ready to go. Open a new tab. Try the website URL. The header is displayed, but there is no data. Open the developer tool. There is a problem with CORS, cross-origin resource sharing. Because CORS is not enabled by default for Azure Function, we need to enable it for the website. Let me copy the origin of this website. Go to the Function app on the portal. Navigate through API, CORS. We see allowed origins. There are some origins added by Azure by default. We add a new one, paste the origin of our front-end website, save the change. Now let's switch back to the website. Reload the page. Now we see the data. This page is very simple, but remember we have all the code operations available at the back end. So potentially we could work on the front end separately, add more features on weak plans like add, update, delete. But I think you got the idea. Let's move on. We also want to know what will happen if I input a wrong page name. So let me test it. ABC is a page doesn't exist. The 404 page we defined before is shown. Now we have finished the whole process on front end, back end, and the database from local environment to Azure. When the Azure resources are no longer needed, we can easily destroy them. One of the easy ways is to go to the resource group on the portal. delete the resource group. All of the resources within the resource group will be deleted. Now we have a full-stack serverless app up and running on Azure. We have walked through all the steps how to come to this point. However, you may think about on-premises or other cloud platforms, how to deploy the app to there. We will talk about this in the next video, the final part of this video series. Thanks for watching.